Welcome to my YouTube channel, Techie San.
Structural units in embedded process. The basic definition is that microcontroller or SoC with dedicated hardware for real-time tasks is used. The key units we use it are CPU core. In case of memory, we use flash memory or RAM. Peripherals, we use GPIO, UART, and ADC. In case of buses, we use AHP or APB. Okay. So the basic block diagram for embedded system. So how we have it is that we have basic core unit, embedded processor. Okay. Peripheral devices to connect it to outside world. These two things are hardware. These two things are hardware. Embedded processor, it is a core CPU core. And peripheral devices to connect it with your output devices. Both are hardware. You have many devices. This is a basic architecture. And in case of software, you have application, embedded, OS. Okay, you need an OS software to integrate all, to control all this hardware devices. Okay, so you feed input and you get the output. Hardware architecture for embedded system. Okay, see, you have a basic CPU, that is a microprocessor. You have a microprocessor. You have separate memory unit. You have separate input-output modules, which is connected to external devices. Okay, this architecture will differ in different microprocessor and microcontroller. Okay, the basic hardware architecture is that you have a CPU, you have input-output module and memory. All this is connected through system bus. Okay. Central processing unit. Arithmetic logic unit. Registers like data registers, address register, and status register is used. Pipeline stages. Fetch, decode, execute, and write back. These are the stages that is run, that is executed in pipeline stages. With architecture, CPU with architecture, there are two architectures, Harvard architecture and von Neumann architecture. Okay. Normally, we'll have a simple code snippet with ARM architecture. Von Neumann architecture. In case of von Neumann architecture, it has only one memory. Both data and instructions will be available within the same memory. Both data and instructions will be available within the same memory, and it has only one memory. Okay. CPU will be in another, CPU will be connected to the memory through the system bus. This is von Neumann architecture. And next is Harvard architecture. In Harvard architecture, you have two separate memories. One for program instructions and one for data. So for program memory, you have separate memory, and for data, you have separate memory. All the codings, what the system has to do, that will be stored in the program memory, and whatever the data that user gives in, that data will be stored in the data memory. This will be connected to the CPU through the system bus. Okay. It has address bus and it has data bus and instruction bus. Okay. These are things that is available with Harvard architecture. Within CPU, it is the same thing. You have instruction register, controller, data channel with input and output. Okay. This is Harvard architecture. And the next architecture is CISC architecture. Complex instruction set computer architecture. Okay, what does that? The number of instructions will be more in this case. It has large number of complex instructions with the CISC architecture. So, some which can do multiple tasks in one instruction. Within a single instruction, it does multiple tasks. That is CISC architecture. Okay, the characteristics is that multiply loads two values from the memory into separate register in CISC. Okay, normally if you want to multiply two values, 5 into 4. Okay, 5 will be stored in a register and 4 will be stored in another register. Okay, that is the first thing. And next thing is that minimum possible instructions by implementing hardware and execute operations. Okay, instruction decoding logic will be very complex in case of CISC architecture. One instruction is required to support multiple addressing modes. Less chip space is enough for general purpose registers for instruction that are operated directly on memory. Various CISC designs are set up two special registers for the stack pointer handling interrupts. One is referred to as complex instruction and requires program for storing functions. These are the key characteristics of CISC architecture. Okay, there's a simple processor, IBM 370, VAX11 or 780, Intel 80486. All this is CISC architecture. It is built with CISC architecture. All these processors are built with CISC architecture. In case of IBM, it is 32-bit processor and 4-bit floating point registers are used. In VAX register, in VAX processor, it is 32-bit processor and it supports number of addressing modes while executing the instructions. Okay. In case of Intel, the instruction vary lengths from 1 to 11 and it has 235 instructions. The length of the instructions is very high. Here it is 235 instructions. RISC architecture. It is reduced instruction set computer. It has fewer instructions, very fewer, and is also simpler instruction. Very simple thing is if it is PIC architecture with RISC architecture, it executes everything. It takes only one clock cycle. Whatever the except the branch instruction and few set of instructions, everything will take only one clock cycle. That is the advantage of RISC architecture. But in case of CISC architecture, it will take multiple clock cycles for single instruction. Okay. So each instruction does only one small task. All instructions are usually same size and executed fast. RISC architecture characteristics. Simple instructions are used in RISC architecture. RISC helps and supports few simple data types and synthesize complex data types. RISC utilizes simple instruction modes and fixed length instructions for pipelining. RISC permits any register to use in any context. One cycle execution, the amount of work that a computer can perform is reduced by load and store instruction. Okay, RISC contains large number of registers in order to provide various number of interactions within the memory. RISC pipelining is easy as the execution of instruction will be done in uniform interval in time. Okay, it takes only one clock cycle. So you can predict If it is set of instructions if you convert in high level language, it is converted to assembly instructions. From assembly instructions, you can easily calculate how much clock cycles it takes for that program. You can easily evaluate how much clock cycle it takes. It is very predictable. In case of RISC, more RAM is used to store assembly instruction. Reduced instruction need a less number of transistors in RISC. RISC uses hardware architecture model, means it is hardware architecture. A compiler is used to perform the conversion operation, means to convert high-level language into code of its form. Memory hierarchy. It may be cache, it may be SRAM, or it may be flash. In cache, the basic purpose is that it is fast access, CPU close. So, example L1, L2, cache. SRAM, it is for fast volatile storage, and MCU internal RAM. Flash, it is non-volatile code.
Thank you, friends.